Welcome! Ever wondered how we can make our industrial environments, especially dynamic ones like modern automobile factories, truly safer? My project explores exactly that, building an AI-powered system to proactively prevent accidents. My project takes a dual approach. First, we have the core brain, an AI model specifically trained to detect personal protective equipment or PPE on workers. You're looking at its interactive demo right now, built with Streamlit. Watch how it analyzes an uploaded image. It accurately identifies individuals, their helmets, and vests. Based on these detections, it immediately tells us if a worker is compliant or, critically, if they're missing essential safety gear. It's like an automated safety inspector processing images instantly. This is all powered by deep learning, a trained model working behind the scenes. Here's a brief look at some of the Python code that makes this detection possible. Now, how do we bring this detection capability into a live factory setting? That's where our Unity 6 simulation comes in. This isn't just a game, it's a digital twin, a virtual proving ground for intelligent safety systems. Here, we've recreated a modular automobile factory. You can see our assembly lines, robotic workstations, and clearly marked safety zones. This simulation helps us visualize, test, and refine how an AI system would behave in a real industrial environment. And behind the scenes, Unity's C# code manages all these interactions and detection. Alright, let's see this system in action. Welcome to our simulated automobile factory presented by me. This is where concepts meet reality in a safe, virtual space. Every safety system begins at the gates. In our factory, wearing a helmet is mandatory from the moment you step inside. Watch as our worker, correctly wearing their helmet, enters the factory. No issues, they're compliant, and operations continue smoothly. Now, deeper into the factory, we have critical safety zones. Here, around this two-arm robot, we've marked a red zone for restricted access when the machine is active, and a green zone for safe movement. See what happens when our worker enters the red zone while the robot is operating. Oh my God! Immediately, the system detects the breach and shuts down the machine. This instant response is vital to prevent severe accidents. And when the worker steps out of the danger zone, the system clears and the machine safely resumes operations. This isn't just about stopping, it's about intelligent adaptive safety. Of course, moving in and out like this wouldn't be allowed in a real factory, but it shows the system's responsiveness. Notice how they can move freely in the green zone without any alerts. Finally, let's see what happens when safety protocols are overlooked right at the entry point. This time, our worker approaches the factory without their mandatory helmet. As they try to enter, bam! The system instantly detects the missing PPE and prevents further entry, demanding compliance before they can proceed. No risks taken. This project demonstrates a multifaceted approach to industrial safety, from a powerful AI detection model showcased in Streamlit to its real-time application and response visualization within our Unity factory simulation. It's about building intelligent, proactive safety systems that can truly transform our workplaces. Thank you for watching. Alright, so you've seen the pretty pictures and the cool simulation, but let's get real for a second. How would we actually take that Streamlit magic, that PPE detection brain, and put it into a real factory, right? Because a website demo isn't going to stop a real robot. So, picture this. Instead of uploading an image to a website, slap a tiny, powerful computer like a Raspberry Pi right there on the factory floor. This little guy is basically a mini PC, super cheap and robust enough for industrial use. Connected to it, a simple off-the-shelf camera module just like the ones in your phone, but probably a bit tougher. That Raspberry Pi would be running our same PPE detection model, the one you saw on Streamlit. It'd be constantly munching on the video feed from that camera, frame by frame, looking for people, helmets, and vests. It's essentially becoming the eyes and brains of our safety system, right there at the edge. No fancy cloud server needed for every single detection.
Now, the LS actions part, when the Raspberry Pi's brain detects something like, say, a worker without a helmet trying to enter an area.
Just like in our Unity demo, it doesn't just print violation to a console. Oh no. It's connected to the factory's IoT, Internet of Things environment. This IoT environment is basically a network of smart devices, programmable logic controllers, PLCs that manage machines, smart lights, even automated gates. So, when the Pi shouts helmet violation, it can immediately send a signal to that IoT network. This signal could trigger a local alarm, flash a red light at the entrance or even lock down an automated gate until the worker complies. Or if it detects someone in a restricted zone, it can send a direct command to the PLC controlling that robot arm, saying, "Hey, stop the show! We've got a person too close." Just like you saw in Unity. It's about taking that powerful AI from our nice clean code and putting it directly where the rubber meets the road, giving factory operations that instant automated safety net. Pretty cool, right? It's not just theory, it's totally achievable with today's tech. Thank you, everyone.